All right, good morning. Today we're going to be looking at the midterm review that was posted to Canvas. First one we have here, what is the slope and y-intercept of this line? So this is pretty straightforward. We just need to put this into slope-intercept form by solving for y. So we'll move the x to the other side, giving us negative 2y is equal to negative 6x plus 10. We'll divide by negative 2, everything by negative 2, giving us y is equal to 3x minus 5. So the slope is the coefficient of the x, 3 over 1. The y-intercept is the constant, which is negative 5. So 0, comma, negative 5 would be the y-intercept. Which of the following is the correct graph for this? Well, first thing we would have to do is solve for the y. So we got 4x minus y greater than 2. So solve for the y, minus 4x, negative y is greater than negative 4x plus 2. Divide by negative 1. Remember, when you divide by a negative and you're working with an inequality, then the symbol should flip around. Okay, so this is our equation here. The y-intercept is negative 2. The slope is 4 over 1. And it's y is less than, so it's going to be a dotted line shaded below. Okay, so we're looking for y-intercept at negative 2, which is either a or b. So not this one, not this one. Dotted line, they're both dotted line, shaded below. Letter A is shaded below, so it's going to be letter A here. The sum of three numbers is 14, so we have three numbers, x plus y plus z, and the sum of those is 14. The largest number, which we'll say is z is 4 times the smallest number, which we'll say is x. The sum of the smallest number, so x plus 2 times, and twice the largest number, so 2 times z, is equal to 18. What are the three numbers? So what we have here is a system of equations. Now, using a quick substitution, because I see that z is equal to 4 times x, I can actually replace the z in this equation with 4 times x. So I have x plus 2 times 4x is equal to 18. So that's x plus 8x is equal to 18. So that's 9x equals 18. Dividing by 9 tells us that our smallest number x is equal to 2. Okay, which means that our largest number is 4 times x, so that's 8. And the sum of all these numbers is 14. So 8 plus 2 is 10. So this one must be equal to 4. So 2, 4, and 8 are our three numbers there. Rate of change for Karen's marathon here. What is the rate of change between hours 2 and 4? So if we look at hour 2, she's right here at 9 miles. And if we look at hour 4, she's here at 18 miles. Okay, so the rate of change is going to be the slope between those 2 points. So it's going to be up 9, from 9 to 18 is up 9, and over 2. So the slope, rise over run, is 9 over 2. And that's our rate of change between hours 2 and 4. What is the product of 8 plus 2i and 2 minus 6i? So the product would mean we have to multiply these together, which means to use the distributive property. So 8 times 2 is 16. 8 times negative 6i is negative 40i, or 48i. 2i times 2 is 4i. And 2i times 6i is negative 12i squared. Now, one thing to keep in mind, I squared, I is equal to the square root of negative 1. That's the imaginary number. So I squared is simply negative 1. So I combine these i's, so it's minus 44i. But this 12i squared minus 12i squared, that becomes negative 12 times negative 1, which is positive 12. So 16 minus 44i plus 12. Well, if you combine the 16 and the 12, that gives you 28. So we're looking at 28 minus 44i is the product, and that's a complex number. Okay, just like these two are complex numbers, this is also a complex number, 28 minus 44i. Very important to remember, I squared is equal to -1. What are the solutions to the quadratic equation? This one cannot be factored. We can try to factor it using this method, but it's not going to work, so we're going to have to move on to the quadratic formula. Negative b plus or minus the square root, b squared minus 4 times a times c, all over 2a. Okay, so we'll replace a, b, and c with 1, 3, and -2. So b, so -3 plus or minus the square root of b squared, so 9, minus 4 times 1 times -2, so plus 8. Okay, because it's -4 and -2, which is positive 8. And that's all over 2 times 1, which is 2. Okay, we're going to simplify this. -3 plus or minus the square root of 17 all over 2. And the only thing that we would simplify here would be the square root of 17. But that can't be simplified because 17 does not have any perfect square factors. So this would be our answer here, -3 plus the square root of 17 over 2, and -3 minus the square root of 17 over 2. This is our two solutions here for x. What part of the quadratic formula can be used to determine the types of solutions an equation has, real or imaginary? Well, if you look at the quadratic equation, the only way that we can have imaginary solutions is if you take the square root of a negative number. Okay, so this part underneath here, b squared minus 4ac, if that is a negative, if you evaluate that expression and it's negative, then your solutions are imaginary. And if you evaluate that expression and it's positive, then the solutions are real. So what part? This part, b squared minus 4ac. That part will tell us whether our solutions are real or imaginary. Solve the following quadratic by completing the square. Completing the square requires us to create a quadratic that has the same two factors. The first part of this is to get the 9 to the other side. X squared plus 8x equals 9. The next part of this is to add a number to the left side and to the right side because we have to, so that when we factor the left side, both the factors are the same. Okay, the idea is when I factor the left side here, both factors are the same. Well, in order for both factors to be the same, they would have to add to 8 and be the same number. Okay, so the only numbers that add to 8 and are the same are positive 4. So both factors would have to be x plus 4, which means the number that I would have to add would have to be 4 times 4, which is 16. 4 times 4 is 16. So I'd have to add 16 to both sides here. Adding 16 to the left side means that this can be factored into x plus 4 times x plus 4, or x plus 4 squared. The right side just gives us 7. At this point, I can now solve this by square root method, because this is a pretty easy equation to solve. I just take the square root to get rid of the square, leaving me with x plus 4 is equal to plus or minus the square root of 7. And then we subtract 4, so -4 plus or minus the square root of 7. And that's my two solutions there. -4 plus the square root of 7 and -4 minus the square root of 7. And completing the square pretty straightforward once you know the trick there. Given the graph of f of x and g of x, what is the equation for g of x? Okay, so for this one we have to remember our transformations, okay? So we have left, right, we have up, down, and we have reflection that flips it over, okay? The left and right transformations affect the x directly, okay? So you're looking for a number that affects the x directly if it is left or right transformations. Up or down transformations will be on the outside. And then to flip it over, we have a negative sign outside. So we are looking for, this has been moved down 4 units, And it's also been flipped over. So we're looking for those two transformations. So first of all, we need a negative sign outside because it's been flipped over. So it's not B because it doesn't have a negative, and it's not D because it doesn't have a negative out front. A and C both have a negative out front. Now this is a vertical shift. So we're looking at -4 on the outside. Okay, letter A has -4 on the inside. That's actually a shift to the right by 4 units. We're looking at letter C, which is a shift down by 4 units because it's on the outside of the x squared. It's outside. So letter C is the one we're looking for that describes the green graph here. Number 10, which of the following represents a shift left by 2 units and down by 1 unit from f of x equals x squared? So left, 2 units left would be a +2 inside the x here. Okay, so +2 inside the x, and 1 unit down would be a -1 on the outside. So +2 on the inside, -1 on the outside. So we're looking at B here because it's got the +2, that's a shift right 2, and -1 on the outside, that's a shift down 1. All right, given these two functions, f of x and g of x, where are they equal to each other? So first we need to take the two functions and set them equal to each other. So this function is equal to the other function. Once we do this, this is now a quadratic. The way that we solve a quadratic is we first have to set it equal to 0. So I'm going to subtract 4x because I need the right side equal to 0. And then I'm going to add 1 to get rid of that -1. So I'm looking at 3x squared plus 11x minus 4 equals 0. Now you can solve this a couple of different ways. You can use the quadratic formula, but this one can be factored, okay? In the top is a times c, which is -12, and the bottom is b, which is +11. So two numbers that multiply to -12 and add to 11 are +12 and -1. So I can split the middle term into 12x and -1x. I can factor the GCF out of each group here. GCF of the first group is 3x, leaving me with x plus 4. GCF of the second group is -1, leaving me with x plus 4. So my first factor is x plus 4, and my second factor is 3x minus 1. And those multiply to make 0. So my solutions will be the x values that make each of these factors 0. So I'll take x plus 4, which is my first factor, set it equal to 0. And I'll take 3x minus 1, which is my second factor, and set it equal to 0. So one of my solutions is -4. And another solution is 1/3. So I'm looking for one of these two. It doesn't matter which one. I'm looking for one of these two, -4 or 1/3. So they have +4, which is not a solution. They have negative. Here's the solution we're looking for, 1/3, letter C. Which of the following is the graph of y is greater than x squared plus 5? Okay, so first we know two things. It's supposed to be a dotted line, and it's supposed to be shaded above. There's only one of these that's dotted and shaded above, okay? Nope, that's, well, yeah, because this one's solid and shaded above. So that's actually just going to be letter B. This one is dotted and shaded above. It's also a transformation up by 5 units from x squared. Okay, so we can see that it's a transformation up by 5 units, and that's that +5 on the outside. So letter B is our graph. What is the remainder when this is divided by x minus 3? So we would have to use synthetic division here to find our remainder. So my coefficients are 1. There's no x squared term, so that's 0. The x term is -2, and then 4. the 1 comes down, and we're dividing by x minus 3, so we'll put positive 3 on the outside. So I'm just going to multiply and add going through the whole way. 3 times 1 is 3, add those together is 3, 3 times 3 is 9, add those together is 7, 3 times 7 is 21, add those together is 25. So 25 is our remainder here. The volume of a sandbox is given by this expression. One of the dimensions is x plus 3. What are the other two? So first we need to divide this by x plus 3. So I'm going to use synthetic division to do that. So 1, negative 3, negative 10, and 24. The 1 comes down. And I'm dividing by x plus 3, so I'm going to use negative 3, which was my 0. Negative 3 times 1 is negative 3. Add those is negative 6. Multiply those is 18. Add those is 8. Multiply those is negative 24. And that's 0. Okay, so when I divide this by x plus 3, this is my remainder, this is my constant, my x and my x squared, I'm left with x squared minus 6x plus 8. Well, now I need to factor this. Okay, so I'm going to factor this now. So positive 8 in the top, a times c, b in the bottom. Two numbers that multiply to 8 and add positive 8 and add to negative 6 are negative 4 and negative 2. Since there's no a value here, I can go ahead and I don't have to do by grouping. I can go ahead and assume, well, since the a value is 1 is what I mean, is that both of these, they factor into x minus 4 and x minus 2. So the other two dimensions were x minus 4 and x minus 2. Factor 125x cubed minus 64. This is a difference of two cubes. 5x cubed minus, I think that's 4 cubed. Yeah, 4 to the third power. So our formula for a difference of two cubes, a cubed minus b cubed, is equal to a minus b, a squared, plus a times b, same, opposite, always positive, plus b squared. Okay, so in this case, a is 5x and b is 4. So this would factor into 5x minus 4 as our first factor, 25x squared, okay, squaring the 5 and squaring the x gives us 25x squared, plus, same, opposite, always positive, so plus 20x, multiply these together to get a times b, 20x, plus 16, all right, and that is how it factors as a difference of two perfect cubes. What are the zeros here? Okay, so the zeros would just be setting each of the individual factors equal to 0 and solving. So 6x squared plus 6 equals 0, 5x plus 2 equals 0, and x plus 3 equals 0. Well, this one's relatively easy. We get x equals negative 3. That's one of our zeros. Subtract 2, 5x equals negative 2, divide by 5. So our other 0 is negative 2 over 5. And then this one, minus 6. 6x squared equals negative 6. Divide by 6. X squared equals negative 1. Square root both sides to get rid of the square. That gives us plus or minus. So x is equal to plus and minus I, because the square root of negative 1 is just I. So there's our four solutions, negative 3, negative 2 over 5, positive I, and negative I. Number 17, which pair of polynomials have the same in behavior? This would have to be letters A and E, because these would both have the same in behavior because they're both odd degree, 5 and 3, and they're both positive leading coefficients. 3 and 5 are both positive leading coefficients, okay? These are, if you check out B and D, those have different signs in front of them, so they have different in behavior. Even though they're both even, they have different in behavior. And letter C is odd, but it's got a negative in front, so it's got different in behavior too. A and E are the only ones that have the same in behavior. Number 18, which of the following represent this graph right here? Well, x plus 1 squared, x minus 2, and it's got a negative in front, so the right side will be going down. So because it's got a negative out front, the right side will be going down, so it's not c and it's not b. So at x plus 1 squared, that means it should be touching at negative 1. And at d, it's crossing through at negative 1, so that one's not correct. Okay, d is crossing through. Since we have this squared here, it should be touching at negative 1, so A is going to be our correct answer here. And that's all of, oh, nope, we got one more problem. Number 19, which of the following is the solution to the equation square root of x minus 4 plus 3 equals 6? We could solve this one, but since it's multiple choice, we can just check these by plugging in. Okay, so we take A and we plug in negative 5. That gives us negative 9, which we can't do that to solve this because it's not going to give us a solution. We need a positive under the radical, so it's not A. If we do 4, then we have 4 minus 4 is 0. Square root of 0 is 0. 0 plus 3 is not 6. Okay, we need this under the radical. Since we're adding 3 to get it equal to 6, under the radical needs to be 3 is what has to happen here. Let's plug in 13. So 13 minus 4 is 9, and the square root of 9 is 3, and 3 plus 3 is equal to 6. So it is letter C, and all we had to do there was plug those in to see which one of these was a solution. And you can check D if you want to see if D is a solution. 20 minus 4 is 16. Square root of 16 is 4. 4 plus 3 is not equal to 6. It's actually equal to 7. So 20 is not a solution. The only one that is 13.